Hello Blenderphiles, welcome back to the node concept. And yeah, we have been quite off because I've been busy, and that's why we were not able to make some tutorials. And today we are back and we are going to do the light path as we mentioned in our last video. And as I have been busy, I was not able to do some research work on the light path, and thus Shubham, who was at home free, he did all the research work and he created this blend file. So it's full of many different things on each of the layers and full of materials and scene setups and things. So he'll be explaining you every single thing that's there in the light path. And so let's just give it to him. Ta-da!
Okay, so the light path node is actually quite a big node. So if I add an input light path, and as you can see, it has many outputs, and I've created many layers also, each with a different output explained. So back to the first layer, let me delete this here, and in this one, yeah, there's this is camera explained. Okay, so is camera array, it basically gives the output of whether a 0 or 1 depending upon the ray of light which is falling on it. Is it coming from camera or not? So is camera array, if 1 means the light is coming from camera, and if 0 means not. So basically wherever it is 1, that will have the shader associated with it in the mix shader, whatever will be visible through the camera, and the rest will be what's calculated by the scene. So if I just press Shift Z, then you can see it's emitting light here because of this first input, and it's visible as a diffuse of red color to the camera because of this second node. If I just plug this into the surface, then it will be visible as a emission only through the camera also. But this way you can have your lamps, some different material as visible from the camera whenever needed. So that's about the is camera array. Then the next is the is shadow array, and basically it gives the output of 0 or 1 depending upon whether it is a shadow array or not. So it will give an output of 0 wherever there is not a shadow array of this object, like wherever the shadow of this object is not present, and a 1 wherever the shadow of this object is present. So if I just plug in the diffuse, so you can see that here it casts a shadow, which if I remove this lamp it won't. So Alt H. So here you can see it casts a shadow. So here the output of this is shadow array will be 1. But here it has no mesh data. This object has no mesh data over here, so we cannot actually plug in another diffuse shader, because if I just make this diffuse shader with blue color and plug this into here, it will have exactly the same shadow as this one, because shadow is independent of the color over here. So if I just make the mix shader, there will be absolutely no change. But if I make this transparent shader and I plug this into the surface, then you can see as the light passes through it, and it's blue in transparent, so light also becomes a blue color, and the shadow it casts is also blue. But the object itself looks weird and not realistic. So we can have a green diffuse shader for this surface and a blue for the shadow. And if I just press in the mix shader, then you can see it has a blue shadow with the green mesh surface. So that way you can change the color of your shadows. You can keep it completely black, which is the default one, but if you want like some lighter shadows, you can have this way also. So you can see there's some lighter shadows with respect to this, really dark, somewhat light. So that's it. And basically light paths are generally used to fake stuff. Cycles is already giving real outputs, realistic outputs as much as it can without the use of this light path. But light paths can help to fake some things, and also somewhere to increase render time by just removing small mistakes. So now in the second layer I have this object which has a is diffuse array. So before that, let me plug in a simple diffuse shader, and here these balls have a diffuse shader of themselves, and as you can see little bit of reflection also happens due to this diffuse shader on these balls, and because the object itself is red, the balls have a red reflection because of that. But sometimes you may need some other reflection like of a blue color. Okay, so this is diffuse ray, these is words, is camera rays, shadow rays, diffuse ray. This means that it checks the ray which is being reflected by the object, whether it is a diffuser or it is not. So wherever it is, it gives a 1 value, true value, and wherever it is not, it gives a 0 value or false value. So that's why you'll always have a 0 or 1 value for these things, all these initial outputs, but not for these. Okay, so is diffuse ray, it checks whether the reflected ray, is it being received by an object as a diffuse source, or it is a glossy source or something else. So if the object is a diffuse source, which is currently is because diffuse, so there it will have a 1 value, and wherever it is not, like here it is not getting reflected, or whether if the object is glossy, like if I make this glossy, then it will not have a 1 value over here. So if I plug this mix shader over here, then you can see wherever it has a 1 value, then it is being manipulated as diffuse or blue color. So here the light which is getting reflected by an object of red color, and it's entering this object which acts as a diffuse ray, it thinks that this object is actually of blue color. It takes into this shader consideration. So it can get a little confusing, but the basic thing is that these light paths, especially this is diffuse ray, is glossy ray, and all these, they are majorly used for the initial object who you want to fake, not these receiving objects. They will just receive with the simple shaders, and this object which you want to fake should have these is rays. Otherwise it can sometimes get really confusing, really confusing. When I was making it, sometimes I also got confused. Okay, so now the layer 3 is a similar scene setup, but here I have the is glossy ray, and these materials, they are glossy, so that's why they'll work over here. So again, it's the same principle that whenever they receive the light, because it is a glossy source, so here it will be 1. If I just plug in the is diffuse ray, then as you can see it is not 1, because these are glossy source and not diffuse source, so they are accepting the glossy rays only and not the diffuse rays. So if I just plug in the glossy ray, then you can see the red object has a blue reflection because of this simple node setup. And then fourth layer, there it is the is singular ray. Now this is almost the same as is glossy ray, but it only works when the receiving source has like very sharp reflections. So if you gloss shader with sharp, or even a normal GGX with roughness 0, but if you increase the roughness, then it will no longer be a singular ray. It will actually accommodate many rays over here. It will not be a singular ray, so it will not act like that. So yeah, 0, non-zero, it's the same thing. Now the fifth layer, I have this is reflection ray. Now you can get confused between is reflection and is glossy ray, or is singular maybe, but they're actually different. So is reflection ray, it basically accommodates for all the reflections of diffuse, glossy, singular, all three are combined into this is reflection ray. So whether the source is a diffuse or a glossy, it will, or has a high roughness, it will always work. So you can just do that, or instead of using this, you can even use the is diffuse ray and is glossy ray and add them with a clamp value. It will also give exactly the same results, and just like that. Although you may not even need this, is reflection ray is only better. If it's provided, why not use it? Okay, so sixth layer. Now here we have the is transmission ray. Now the transmission, it occurs when an object which is has a glass shader or refraction shader, or even for that matter, where is it, translucent shader. So whenever the light passes through it, it gets it gets interpreted as a transmission ray. So whenever it's a transmission ray, it will give a one output which will be interpreted as a blue diffuse shader. So if I just press Shift Z, then you can see whatever part of the object is getting transmitted to this glass shader is blue and the rest is red. Same goes for refraction and translucent. Okay, so now the seventh layer. Now we have ended all these is things. The next comes is the ray length. What the ray length does is whenever a ray falls on the object, it gets bounced off, and then let's assume it falls like this, it gets bounced off like this, and it again gets bounced off. So between these two bounces, what is the length of this ray? That is being interpreted by this ray length thing. So it might seem a bit technical, but what's basically it gives is like at an instant how thick of an object is. So let me just remove this grease pencil, and now if I just press Shift Z, then you can see I have a mix of two emissions, and wherever it is thicker it has this blue color more, and wherever it is thinner this has this white color more, and I use this multiplier to decrease its value to give somewhat between 0 and 1 because earlier the values are too big. So if you can just see around the mesh, you will notice that wherever it is thinner it is white color, and wherever it is thicker it's blue color. And this is also view dependent for some reason, because the length it changes. It's very small right now, it's big, so it really needs to be tweaked well. So next is the scene setup, and this time it is the ray depth thing. So let me first show you a simple glass shader. So if you have some kind of a mesh with a glass shader, then more often than not you'll see these dark black things over here which really mess up your scene sometimes, although they are quite realistic, but many a times you don't want them. So you can either add in a subsurface modifier to remove them, but that will increase your mesh by a lot. So there's a workaround for that using this light path node. So using the ray depth, what it essentially tells is how deep the ray is inside the mesh once it has passed through, something like that. So if you just follow this simple node setup where I use this greater than node to with a value of 2, so I can limit the light to 2 bounces, and then this transparent node. So if I plug this mix shader here, then you can see all those black spots that were here, they all get removed over here. So that's also quite nice, and sometimes it loses its realism. If you can see, it doesn't look much glass like now, so you can adjust this value to maybe 3 or 4, and it will give you a realistic glass shader without all these black things. Almost the same result. And if your object is not much in focus, then this is actually quite good. It also helps to save some memory also. Here there can occur some cycles errors which raise these black things, but it will all be prevented over here. So next is the 9th layer, and here, where's the notary? Yeah, here it is. So here I have this transparent depth, but before using that, let me just show you what kind of material I've made. So here it's a mix shader of emission and transparent with a Fresnel as a layer weight, and on the volume I have a mix shader of volume absorption and emission. So now if I just press Shift Z, so you can see that it's transparent in many areas, and in some areas it appears to be dark green and some areas appears to be light green, and it also emits these blue lights. So wherever it is light green, it is due to this forward area of the mesh, and wherever it is dark green, it is because the forward area and the backward area both are getting contributed to the material because it is transparent after all. So the black area is also visible at the same time as the forward area, and you can see that it looks really bad. So now if I just put in a mixed shader with another transparent shader, but this time the transparent depth as a factor, and I plug this into the surface, then you can see wherever there was overlapping of meshes for some sort between the front face and the back faces, these back areas, that will get removed. So what this transparent depth gives is basically how deep the transparency is from one point to another, and based on that only, if I just add in a transparent shader, then it will make all those back faces as transparent for this front face, so it will not get rendered at all, which will make it look a lot better than this one. See, really overlapping, much cleaner. And the next one was this transmission depth, which is basically the same as a transparent depth, and it gives how much the depth of the transmission ray is. And transmission ray is like when light passes through this object, and it's quite similar actually to transparent depth, but I haven't actually found a real good node setup to explain this, so I haven't made any other scenes. If you find something, you can always tell us in the comment section. And I guess that's it for this tutorial. Let me see, is camera ray, yep, is shadow ray also covered here, is diffuse ray, is glossy ray, singular, is reflection, right? Yep, is reflection, then is transmission, ray length, ray depth, and finally this transparent depth and transmission depth. Also, transmission depth is really new. It was introduced around 2 or 3 versions ago, while all of these are much older. So yeah, I guess that's it for this tutorial.
Okay, so that was really nice of Shum. I guess he explained you everything. So that is basically it for this tutorial. And yeah, we did look up on Google for some more answers on this transmission depth thing and other things, and we found one really good tutorial by CG Cookie, and you can see there's a link in the description. You can see the video. That's really awesome. It's all on this thing, this light path node. And yeah, so in our next video we'll be covering up one other more very important node, which we call is the Fresnel and layer weight. We'll be combining them, so because these are very similar looking nodes. So with that layer weight, these two nodes. So next coming these two things, so stay tuned, and you can follow us on Facebook at facebook.com/Blenderphile, and do subscribe to stay tuned, and we will see you in our next video. Till then, happy blending and keep experimenting with these things. So see ya.